in the beginning my goal was to plot a tubular thing that had its center in this helix. This is an helix. So I wanted to draw a circumference that had this helix at its center. So what I have here, this is the parameter t, but in order to make calculations easier, I calculate the arc parameter. So in the end I get this expression for the helix, this one. So in order to get that circumference, and in order for it to be orthogonal to the helix at every point of the helix, I need the normal and the binormal vectors. And this is what I have here. I have this expression for the helix, gamma, as a function of s, and then I calculate the tangent vector, which is this expression, and I also calculate the normal and the binormal. The normal is this one, and the binormal is the cross product between the tangent and the normal. So once I have the expressions for those two vectors, the circumference will be a function of s as it runs along the helix, and theta, which will give me the whole circumference. So the center of this circumference as a function of s will be each point of the helix given by this plus the radius of the tubular, and then cosine of theta times the normal plus sine of theta times the binormal. S running in some interval of r, and then theta between 0 and 2 pi. So if I join everything, I get this expression. So now the only thing that remains is to write everything in Mathematica, for example, and I'll show you first the gamma, which is here, the helix. I plot the helix with this. Then the next step was to write the expression for the tubular thing, for the tubular helix, which is given by this, and now it's just a matter of plotting that expression. Okay, next, I wanted to make the helix a bit longer, so now I have this. And then a question came to my mind, and this question was, why don't I plot, or with an animate, for example, so that I can see at each point of the axis of this tubular thing, and we can run along this axis and through. So and I ended up with a problem that I can't solve, and it is that the viewpoint, I have this view vector function, or this view vector option in Mathematica, and you must give this expression the point at which you want to do the view and the vector and the direction of that specific view. But I have to do this dynamically. This is just evaluated at point 0, but I want to do it for every s in the tubular helix. And this is where I found the problem, because, for example, if I do this with, instead of animate, I wrote manipulate of this, I write parametric down, which gives the plot in this, and then some enough points for the plot to not be a potato, and then view vector dynamic this, and this option for the manipulate. But if I run this, I get this, look. And that happy turn, I don't know why it happens. Why does it happen? Look, you see? Why does it do that? It shouldn't do that. And I think the calculations are correct, but it gives this. And it's quite strange. So let's see if you can come up with an answer. Thank you.